At this point, we should start to recognize some of these words. Like when you see modeling, and I answered that question in yesterday's test, but modeling is coming up with a model, which means coming up with an equation for things. So these are the terms that you're going to have to get comfortable with. So you're going to take data, which is like in tables and stuff like that, and come up with a model or an equation, okay? And we're obviously doing exponential functions. So we're still carrying on with our exponential functions. We start with the basic one. So this one says it's just a regular exponential function. And yesterday on the test, I told you it didn't matter. Shh. It didn't matter if you were putting, God bless you, things in terms of geometric or exponential. But now we're shifting. We're in exponential. So can you use a geometric equation to find the exponential model? Yes. But our answers are going to be y or f of x equals, there's a number, times the whatever's being raised to the power. So this has to be in this format now, okay? No longer can I leave it as a sub n. So you have your typical functions in which there's and the way we would know this is an exponential function is to find the ratio, right? 1, I look at the x coordinates, they are increasing by 1. Then I look at the f of x, or the outputs, and it would be 6 over 3, which is 2, and 12 over 6, which is times 2, and 24 over 12, which is times 2, and 48 over 24, which, again, would be multiplied by 2. So our ratio, which we called r when we did it with exponential function, with geometric, is b in this function. So the b would be 2, and it's going to be raised to the power of x. And then you can use the data you're given to find the first term. Now the first term would be x minus 0, which means it's the 0 term. Or you could literally plug in, if you're not given that term, you could be able to plug in an input value as your x, an output value as your y, and find a. So if I didn't know a from my chart, I would get to this point. I would plug in a coordinate point where 3 would be my y, 0 would be my exponent, and I end up getting that a is 3. This time I don't need to do that because it gave me the 0 term, or where x is 0. But if I didn't have that term, and there's a couple ways to do it. I could also just like divide by 2 if I had that, right? But the other way to do it, and you're going to need to understand this because moving forward we're going to have to do something with this, is to take an equation and plug in as your input value any of those x's, your output value the corresponding y, and then solve for a. So I could have picked 3 and 24 and done the same exact thing. Made the 24 the y, made the 3 the exponent, and I would have gotten a of 3. Questions so far? Your ending answer should look something like this. There should be something in the place of the a, and there should be something in the place of the b. So that also happened on yesterday's. Like some of you left a n on the left, which is fine. I took it for yesterday. It will need to be y moving forward. But then you left a 1 where the 3 is. You have to have a value there.
Could we put f of x?
Yes, that's fine. From now on, you can do y or f of x. But normally it will say f of x. Yeah.
And you don't combine anything.
You do not. This is not the same thing. This is not equivalent to 6 to the x, right? Only thing getting raised to the power is the 2. So that is wrong. Not only is it the wrong format, but it's also wrong because it's not the 3 that's being raised to the x. All right, so this is where it gets a little weird. What happens if there's a vertical shift on it? You will no longer see the values being proportional. Remember we said this a couple sections ago, that if the original is exponential, a shifted one may not be exponential anymore or might not be proportional anymore. So if you're going to set this up, if I look at my x values, they're going up by 1s, but the y values are not proportional. So 1 over negative 2 is not the same thing as 7 over 1, is not the same thing as 19 over 7, is not the same thing as 43 over 19. But if you graph this, it will look exponential. So if without a graphing utility, the way you would identify the rest of this equation is you have to find the actual ratio that it should be, but it's not of your original values because that's not the same. We're going to find the ratio of the first difference. So remember, first difference means literally subtract these. 1 minus a negative 2 would be 3. 7 minus 1 would be 6. 19 minus 7 would be 12. And look at the pattern that's forming with my differences. What do we think the next difference is going to be? 24. 43 minus 19 is 24. Now I can find my B, formerly known as R, which would be 6 over 3, 12 over 6, 24 over 12, and all of those tell you B is 2. So far, I have Y equals A. I don't know. Well, I do because it's negative 2. But B is 2. X plus K. With me so far? So I use that to find the rate. Now I'm going to set up a systems of equation. I am picking 2 of these sets of coordinate points. I'm going to pick the first one and the second one just because they're the easiest, but you literally could pick any of them. And I'm going to plug them into this equation. So the first one, my Y is negative 2. I don't know A. Then it's 2 times X to the 0 power plus K. So I still have 2 unknowns. This simplifies to negative 2 equals A plus K because 2 to the 0 power is what? 1. Then I'm going to repeat that process with my second coordinate point. So 1 equals A times 2 to the first plus K. And 1 equals 2A plus K. With me so far? Now I literally have a systems of equation. 2 equations with 2 variables. You get to choose how you set this up. You can either set it up as a elimination or addition, where your A's and your K's are in line and you combine them. Or you can set it up as substitution. So if I were to do substitution, let's say on the right-hand side, I could solve for K. K would equal 1 minus 2A. And then I take that expression and plug it into the first one. So negative 2 equals K plus 1 minus 2A. I'm going to solve for A. So subtract the 1. Negative 3 equals, combine these two, negative A, and A equals 3. With me so far? Okay, then I'm going to repeat that. Now I need to find the K, right? So I have my A now. Y equals 3 times 2 to the X. I'm still missing K. I can find K by plugging A back in. K equals 1 minus 2 times 3. K equals 1 minus 5. Minus 6, sorry. K equals negative 5. So here is my exponential equation with a vertical shift. We're going to do it again, but again, this long, tedious process is because my initial terms have been shifted, and so I don't get the obvious R. So you'll look at the directions, and it'll either say the function, the data below represents f of x equals a times b to the x, and you just do it the way we did the last way, the nice and easy way, or it will say that plus k, and that's the one you know you have to do the extra work with the systems of equations to solve. Okay, we're going to do one more. So it says below is a table of values for the exponential functions in the form of f of x equals a times b to the x plus k. Write the equation that represents the data. So what's the first thing we had to do?
You have to find the common difference.
Good. 1, I check my x's. They are going up by 1, which they should. Then I want to find the common difference here. So 10, or the first difference. 10 minus 2 is 8. 34 minus 10 is 24. 106 minus 34. 72. What's happening here? Times 3. So it is 216, but But by the time you establish a pattern, I would say you need the 3 points to establish the pattern. But once you do that, it's not like it's going to trick you in the last. Unless it said, is this something? Then you'd have to worry about it. But if it says it is represented by a times b to the x plus k, then you're good. So I know b is 3. So my equation is y equals a 3 to the x plus k. And I'm going to pick 2 coordinate points, 0, 2, and 1, 10. Again, you could pick anything you want. I just tend to pick the smaller ones. So y is 2 when a is a, 3 gets raised to 0 plus k. And again, 3 to the 0 is 1, so 2 equals a plus k. Then I do the second one, 10, God bless you, equals a times 3 to the first power plus k. And I get 10 equals 3a plus k. So this time I'm going to use elimination just so you see a variety of both, because you could pick either one. But you could have solved, again, one of these for one of the variables and kept going. But I'm going to come over here and I'm going to set this up as 10 equals 3a plus k and use these two using elimination. So the goal of elimination is to cancel out one of these variables when I add it, right? What's the easiest thing to change to cancel?
Negative.
Okay, on the first one, make these all negative. And I get 8 equals 2a, these cancel, and a equals 4. So if I want to find k, I can plug it back into either of those original ones. I could grab this one because that was the easy one. 2 equals a plus k, 2 equals 4 plus k, and k equals negative 2. So I get y equals 4 times 3 to the x plus, or sorry, minus 2. Questions? This is the worst of it today. I do have one more example, but I'm going to skip it for now. If we have time, I'll go back to it, but I want to make sure we get through the rest of the content, okay? But it is the exact same process.
How'd you get the K?
You plug the a back into either of the ones we set up. So I plugged it back into the 2 equals a plus k, just because there's not a coefficient on the a. That's the only reason.
But you can't plug it into the Y,
No,
the Y equivalent?
no, because, I mean, you could, but it's more work.
It's like raised to the X, so like what would you raise it to?
What, you'd have to pick a y and an x.
Oh.
Yeah. All right, so example 3 brings back in your calculator. It says the table presents values of the function f for selected values of x. Use a calculator to find an exponential regression to model this data. So remember our linear regression, our quadratic regression, our cubic regression. There's also an exponential one. So when you go to your stat, we're going to enter all this stuff in. All right, so I went to my stat. I'm plugging in -8, -7, -1, and 2. Go back up, go over 30, 40, 158, and 280. Oh, I've got something in there already. Hang on, let me clear it out. Okay, remember I go to Zoom 9 to get all the points graphed in the same spot. So it told me it's exponential. It looks like it's exponential, okay? But this time it even told you that it's exponential. Now I want to find the exponential regression model. So I'm going to stat, I'm going over to calc, and it's 0. So you don't see it on the first screen. If you type 0, it will bring you right there. It says EXP regression. I want to leave all that and I want to store it. So I'm going to go alpha, trace to the Y1 to store it, and hit enter twice. So here is my exponential. Y equals the A, 186.721 times B, 1.251 to the X. Notice the model was not plus K. It won't work if it's plus K, so we won't get questions like that. It will say find it if it's A times B to the X. Then it says, use the model to predict the value of 2.5. So I can either go to my graph, and I could go to, oh, there it's stored. Hang on. And I can go to second, trace, go to value, and do 2.5. And there's the y, which is 326.5957, so 596. Or I could have, from my home screen, done y parentheses 2.5. We good so far? All right, now pay attention because this we have not done yet. The next, Santi, do you want to watch first? Okay, C says, according to the model, when will f of x equal 100? So if I trace this thing, or I go to the table and I try to find 100, it may not be exact. Like I might not be able to find exactly 100 on my y. So the other way we get around this is with the TIs, you can't say y equals, right? Like I can't say where's y equal this. Some of the other calculators do allow that. The way that we get around it is we're gonna graph a horizontal equation with 100. So we're gonna go to y equals, we're gonna go to the next line, and we're gonna hit 100. So I go to a y2, this is gonna be a horizontal line passing through where y is 100. I'm gonna hit graph. I'm zoomed out, right? So you see it. If you didn't see it because you didn't zoom out on that stat plot, then you might have to zoom out to see your line. But that red line is crossing through 100. So how do I find the exact point where they cross? Intersect. Go to second, trace to the calc menu. Remember, we've used value, we use 0, we use max, we use min, but underneath that is intersect. Go to 5, and it's going to take you to the point where these intersect, which would be where y, oh no, I have to highlight it first. 1, your little like spider looking thing, it says first curve. It could be on either the blue or the red, it doesn't matter, hit enter. Then it's going to switch to the other one. I want it to be where these two meet, so I hit enter on the second curve. Guess, yep, take me to the point where they meet, which is negative 2.792. So this is A, this is B, and this is C. Questions? Yep, yeah. All right, hang on, let me go here. So Euler's number is E. It's also called the natural base, and we use it in Algebra 2 when we use logs, okay? You remember ln is the log of E? That's where all this stuff is used. It is referred to as Euler's number because he was the first one to use it, not to discover it, but to use it. The irrational number, it is an irrational number, which means it doesn't end, it doesn't repeat, kind of like pi. And we approximate it as 2.7 when we used to round to the nearest tenth. We will approximate it as 2.718 if you need to keep three digits. It's a growth constant, which means as something increases continuously, it will eventually have a base that is E. Okay, so when it says something increases continuously, we use that as its base instead of a value for where B goes. B would be E in that case. So if you remember PERT has E in it. E is the base. That's what it's used for. So it's called a natural base. And anytime you see something compounded continuously, we use that formula, which is on the next screen at the bottom. So a continuous growth is, we call it PERT because that's what the letters spell, but it is P, which is the principal balance, whatever you put in there, times E to the RT. These other ones are simple growths. They're still exponential, but they're not continuous. So the first is an increase. If I wanted to establish an increase or decrease in growth model, so an increased growth, it would be the first, whatever you're putting in, whatever you're starting, your initial value, times 1 plus the percent increase. So if it is a percent increase of 25%, then whatever I start with is going to get multiplied times 1 plus 0.25 because it has to be in decimal. And then I'd go one step further and say 1.25 to the x. So we're making exponential models from our growth and our decay. If it's a decrease, if it's a 25% decrease, then I'd get whatever I start with, and it'd be 1 minus 0.25x, which results in whatever we started with times 0.75x. So notice a growth, oops, I didn't mean to do that one. a growth is bigger than 1 and a decay or decrease is less than 1. You are literally going to get questions that say, here's an equation. Is it an increase or a decrease? If it's bigger than 1, it's an increase. If it's less than 1, it's a decrease. Yeah.
Aren't these the one that asks like if it's decay or growth?
So if it was bigger than 1, it'd be growth. And if it's less than 1, it's decay. So you can see both. Then you get 2 special ones that are called half-life and double life. If you've taken chem, you've probably heard these. Yes? No? Okay, you might, eventually. So a half-life is when whatever you have loses half of its. So if I start with 1,000, I want to know how long, what's the half-life? It's when it gets to 500. It literally gets cut in half. And the formula you can use is this. Y equals A times 1/2 T over the rate is what H. That's how long it takes. So if it says it loses half its life every 36 days, then H is 36. And I'd start with my value, and it'd be 1/2 T over 36. A double life is the reverse. How long does it take to double? So bacteria, things that grow exponentially, those are doubles, okay? So how long does it take you to double? Now your base is 2. Everything else is the same. So these examples are just to set up the model. A says the value of a car is $68,000 and increases by 1.75% each year. So is this growth? Or, okay, increase or decrease? This is increase. So we're going to do $68,000 times 1 plus the decimal form of that percent, which would be what? 0.0175 to the x. So this would be 68,000 times 1.0175x. B says there is 250 grams of bacteria in a dish. The bacteria doubles every 8 years. So it's 250 times, we're doubling, so the base is 2. To the T over H, H being the number of years or time it takes to double. So T over 8. Or X over 8, it's the same thing. So like your AP questions sometimes use T, sometimes use X, they're all the same. It just depends on what that variable is picked. Question so far? All right, now we're going to actually solve these. So A says Jake lends $20,000 to his friend at an annual interest of 5.7% compounded annually. Use the exponential growth formula. Find the amount owed by his friend after 6 years. So what's the initial amount? $20,000. Is this increase or decrease? Increase. 1 plus, what's the decimal form there? 0.057 raised to the, how long it's in there, which is?
6 years.
6. You could literally type that whole thing in the calculator as is. As long as you keep those parentheses there, it will give you the right answer. So 20, oh, I need another 0 there. 20. 1 plus 0.057 raised to the 6. And this is money. So we're rounding to the nearest cent. Questions on that one? Yeah.
So you could write it as 20,000 times,
Like when you put it in the calculator? Or?
I know what I did wrong. I did 5.7 instead of.
Yeah, that's a lot of money.
680.
Yeah. That's a lot of money. You're basically times by 5, right? Yeah, every time. All right, Elsa invests $200 compounded continuously. So what do we use for continuous compounding? Per, yeah. So this would be the principal, which is 200 times E to the R, which is the rate here, 0.065, times the amount of years, which is 8. So 200, God bless you. E is above the ln, 0.065 times 8. $336.41. All right, the last one, so test prep multiple choice type of question says zebra mussels are invasive. Did you know that? I didn't know that.
What does that mean?
Zebra mussels, like the mussels that are in the little clams. I guess there are zebra mussels and they are invasive. Taking over the world. Okay. The zebra mussels are an invasive fingernail-sized mollusk. We're learning about the environment. That are infesting some of the freshwater lakes in North America. Their population increases on average at a rate of 5% per day. They're taking over. Let 700 be the amount of zebra mussels in a certain lake at time D equals 0, so the very initial part. Which of the following function models the amount of zebra mussels after T weeks? I'm going to let you think about it. Okay, so think about what it's saying, right? First of all, it says it increases. So we're increasing. If there was something like a 0.95, I would have ruled that out because that would be a decrease. It increases on an average rate of 5% per day. So that's the initial amount is per day, right? So if I had set something up and I just wanted to know how many days, now it would be your typical T on the outside. But then it says, let 700 be the initial amount. So again, I would have checked to make sure they're all 700. They are. Before I said I would have checked to make sure the 1.05 is all there. They are. But then it asks which of the following function models the amount of zebra mussels after T weeks. So now it's going from days to weeks, right? How many days are in a week?
7.
So if I want to convert from days to weeks, I'm going to multiply by the 7. So I'm raising it to the 7th power and then raising it to the T power. And when we multiply that, you get 7T. If it was the other way around, if it had said how many per week and it wanted it per days, then it would be the reciprocal because you'd be taking the week and dividing it by the number of days. Does that make sense? That's when it would be 1/7.
Which one would it be?
It would be this one if those were reversed. If it gave it to you in terms of weeks, but then it wanted it in terms of days because the weeks is normally on the outside, but we're saying I want it per day, so I'm cutting it or dividing it. Questions on anything we talked about today?